Hi everybody, hope you're all doing well today. This is Plants Part 2 and we're going to be talking about seedless vascular plants. Okay, seedless vascular plants, they have vascular tissue obviously, and some words you need to know for your test. The xylem part of the plant conducts water and minerals and just transports that all through, seedless vascular plants like ferns. And then the phloem, it transports actual food, more organic nutrients to the plant. So just keep those in mind. Now, vascular plants have true roots and stems and leaves, and the sporophyte is the dominant generation among these vascular plants. It's a generation with vascular tissue. Okay. Now there are two groups of seedless vascular plants to keep in mind. You have your lycophytes, which we'll talk about in just a second, and then you have ferns and things like horsetails, whisk ferns, plants like that. Now, seedless vascular plants, they don't make seeds, but they make windblown spores, and they disperse the spores this way through the wind. Now, here's just an example of some seedless vascular plants, and they did form, a lot of them, through the grape swamp forests, okay, many years ago. And you can still find lots of ferns in places that are warm and wet, like swamps. Now, lycophytes, those are club mosses, and you can find these out in the woods. Basically, the rhizome, which is kind of a horizontal stem, it sends up these aerial stems. Okay, the rhizome. So it's kind of like close to a root is what the rhizome is. And you have sporangia. Okay, and you've also got spores that are highly flammable, and sometimes these spores are harvested and sold as lycopodium powder. Another name for that is vegetable sulfur, and this vegetable sulfur is used in pharmaceuticals, and it's also used in fireworks. It's very flammable. Okay, so that's an example there of lycophytes. Now, ferns, you probably be a little more familiar with. Ferns are most abundant in warm, wet regions, tropical, like rainforests, places like that. Humans have also cultivated them over the years. You can buy them really at like Walmart, Ellis Pottery. You can also find ferns in rocky, dry places. They're really adaptable. They can grow as low growing plants, and they can also grow all the way up to tall trees. Their leaves are fronds, and they grow from a rhizome, which is that, horizontal stem that we talked about in the lycophytes. They have a dominant sporophyte stage, which is 2N, and they produce these spores that fly in the wind, and then the spores are going to germinate and form these little gametophytes, and gametophytes, remember, make gametes. Okay, and so these gametophytes are independent from sporophytes, and just keep in mind the swimming sperm are going to be produced by Antheridia, and then the Archegonia is going to be making the eggs. Now, here's some pictures of ferns. Ferns are usually very decorative, they're ornamental. In some countries, the wood from tropical tree ferns is used as building material. It's actually very tough. It resists a lot of decay and termite damage. Ostrich ferns can be actually eaten as food. Okay, so there's many different types of ferns. Now, here's the life cycle of the fern. Okay, we're going to just take this step by step. You've got the sporophyte. The dominant sporophyte makes these windblown spores. Okay, and in the sporangia, you've got the sporangia located within the sorus, or the sori, on the underside of the leaflets, and you've probably seen that on ferns. They've got these little ball things that are kind of on the underside of it, of the actual fronds. Now, meiosis is going to happen, and spores are going to be made. Okay, when a sporangium opens, the spores are just going to be released into the wind. Okay, and spores are going to germinate. Okay, which is going to have Archegonia and Antheridia. And remember, Archegonia is going to make eggs, Antheridium is going to make sperm. Okay, so you're going from a sporophyte in the beginning to a gametophyte. So you're really going from diploid, okay, to haploid, okay, or half the number, of chromosomes and all. Now, fertilization is going to happen. You need fertilization. You need it to be wet when it's time for fertilization. That's one reason why ferns do so well in warm, wet climates. Okay, and the flagellated sperm are going to swim to the egg within the archegonium. And then the zygote's going to happen when the eggs and sperm get together, and the zygote's going to start developing inside an archegonium. Okay, almost kind of like an egg sac. And then the first leaves are going to appear, and the sporophyte's going to become visible. Okay, and then basically the fern will grow up into a full-blown fern, and so it'll develop these rhizomes, or those horizontal stems going across here, and then the fronds will project up out of that. Okay. Now, whisk ferns. Whisk ferns have these kind of aerial stems, okay, and they don't really have any leaves. The photosynthesis occurs totally in the stems. Okay. And then you have independent gametophytes underground, and you find these out kind of like Arizona, Texas, Louisiana, Hawaii, okay, kind of really all over the United States. Okay, so those are typical type of ferns. They're whisk ferns. Now, horsetails, this always looks like a weed to me, but they live in very moist habitats. The rhizome, or the horizontal stem, is going to make these aerial stems that go straight up, and the leaves are kind of scaly. It's strange because the stems of horsetails are really tough because they're made out of silica, and the early settlers in the United States used horsetails to scour their pots and pans, and they called them scouring rushes. Okay? And horsetails today are still used in a lot of abrasive powders, and so they're really good at cleaning, metals and getting rid of gunky food after your supper. And so anyway, the leaves tend to be real scale like. You've got cones. I will tell you that any part of the rhizome in a horsetail will regenerate. If you have these in your yard, they're very hard to get rid of because they keep just growing themselves back like a typical weed. Okay. But that's what they look like. These are horsetails.